Okay, YouTube, this is going to be a really brief video that I'm doing on the method we use to rationalize a rational expression when we have a radical in the basement. We often do not care to have radicals in the basement of a denominator, and so what we need to do is we need to get that out. And so a method that we have is essentially this. We call this rationalizing the denominator. And you might think that what we could do here is we could square both parts of this fraction, but one thing I do want to point out is this. You may do the same thing to the top and the bottom of a fraction when it comes to multiplying and dividing, but you can't just throw in a squared here, because if you did this you would get, say, like 4/9 here. And what I can tell you is 2/3, for instance, would be 0.66 repeating, and 4/9 would be 0.44 repeating, and those just simply aren't the same things. So what we need to do is something that is a clearly legal move here, which would be take the top and the bottom times the same thing. And so since my goal here is to square the bottom, since that would get rid of the square root, what we'll do is we'll just interpret that as being taken times itself. And so we'll take the bottom times √3, and we just have to do the same thing to the top. And when you multiply by √3/3, consider this, you are just multiplying by 1, which doesn't change the overall value of this expression. So if we were to take the bottom and the top of this times the square root of 3, times the square root of 3, times the square root of 3, we would get on top, we would just get 2√3. And in the basement here, we would get √3 times √3 is √9. Or you could look at this as just saying that the square roots cancel out and we get 2√3/9. Okay. So looking at this next expression here, we have 5/5. We'll take the top and the bottom times the square root of 5. This would be our rationalization. That's what this is called. So we say we have 5√5 on top, and then in the basement we would have just 5. So one thing I want to comment on before we reduce this, simplify it, but it's basically this. In both instances you can see that what happens to this initial expression is that the radical just kind of moves upstairs, and in the basement, oops, this is not a 9 here, this is a 3. I had been thinking square root of 9, I wrote a 9, this is just a 3. But the radical moves upstairs, essentially, and in the basement it just becomes a natural whatever was inside the radical to begin with. So you notice that the 5 now has a √5 on it from the basement, and in the basement here we have just a natural 5. Now this expression here, we can go ahead and cancel out these 5's and we get just √5. And so for instance over here we would have 1 with a √7 next to it now, and in the basement we have just a 7, or we could just call this √7/7. That's the kind of the quick pattern for this. But that's how you rationalize a rational expression. Cheers.